Okay, what we're talking about in this chapter are things called polygons. We've discussed what a polygon is before. Talked about convex polygons, concave polygons, and all that kind of stuff. Okay, first thing we're going to talk about today, mainly today, we're going to be talking about all kinds of different types of polygons. So what we're going to do is we're going to list the types of polygons that we're going to discuss. And we're going to learn some things about these particular polygons. And they all have to do with the number of sides that they have. So let's do this. What if we had, in fact, let's do this. Let's say sides, and then we'll put name. We've probably discussed this before, but let's go through it again because we'll be dealing with a lot of these different figures. Okay, if you have three sides, this is probably the most obvious of them all. What is the name we call a polygon with three sides? It's a triangle. Okay, so let's make a little running list of these things. We'll make a couple lists today. This will be our first one. Okay, everybody writing this down? See a lot of people not writing at all. You should be writing. I shouldn't even have to tell you. Okay, that's part about being serious in a class. Not just my class, but every class. You should have paper in front of you. You should have a pencil in your hand or a pen or whatever it is, and you should be writing the stuff down that I write up here on the board. Okay, this is three sides is a triangle. What about four sides? Now you'd think it's a quadrilateral. That's right. It's not necessarily a square because not every four-sided figure is a square, is it? But every four-sided figure we could call a quadrilateral. So quad and then relateral. Okay, lateral means sides, quad means four. So four sides. Tri prefix is three, isn't it? Let's do some more. What about five? You've probably heard about this, right? It's a pentagon. And then six is hexagon. Seven's kind of a weird one. Sometimes I actually taught out of a book that didn't even have one of these type of names for it. They just called it a seven-gon. I thought that was kind of weird. But some books, and I think this book calls it a heptagon. Heptagon. All right? So heptagon. Eight's a pretty familiar one. You probably see one every single day. It's an octagon. Yeah, the UFC. I never even think of that. But yeah, the fighting thing, you know, they're in the octagon instead of the square and all that. Or a stop sign is what I was thinking about. We probably don't see, you know, MMA stuff every day. I know some of you guys might, but anyway, you're right. They do fight in an octagon. I never even thought about that. Nine, it's probably a word that we don't use all that often, but they call it a nonagon. It's kind of weird. And 10, it's pretty. That's a decagon. Whoops, forgot the C. Decagon. Why deca? What's that? Give me another word with deca as a prefix. It's 10. A decade, right. Okay, decade, 10 years. Okay, is there anything else you can think of? What about the Olympics? There's a event in the decathlon. You ever hear of the decathlon? Okay. All right, here's a name. Now, the sad thing is, you should know this name because he won the decathlon in, I think, 1976. But listen, but you probably know his name for something completely different that's completely shallow, and it just makes me ill anytime I see it. His name's Bruce Jenner. Tell me why you know Bruce Jenner. Yes. See, I knew it. So if I say Bruce Jenner, today you guys think Kardashians, okay? But when I think of Bruce Jenner, I think of him as winning the decathlon I think it was in 1976. Yeah, he was decathlon. He won the decathlon, which is 10 events. Listen to me. Shh, 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 shh. Listen to me. When I think of Bruce Jenner, I think him winning the decathlon, and it's a shame how times have changed, and now people know him as the father or stepfather of the most shallow people in the country. So, all right. Anyway, here we go. Let's see what else. All right, let's do this. What we're going to do now is we're going to talk about the sum of the angles of a polygon. We've already talked about this quite extensively, actually, on one particular type of polygon. We found the sum of the angles of what? A triangle. That's right. Okay, we talked about a triangle. So let's just, I'm just going to just draw some kind of arbitrary triangle. It's not necessarily supposed to be anything. It's not supposed to be equilateral or anything like that. Okay, so there's a little triangle. It's a little bit sloppy. Let's try to get it to line up. There we go. Good enough. Keep it like that. So what are the sum of the angles of a triangle? If I added up angle 1, 2, and 3, what would it add up to be? Okay, so if we had a triangle, and this is where I'm going to make another list. Scooch it down. See, now I can scooch down. Isn't that cool? So let's do this. Let's make another list. And we'll say, here's for the name of the triangle. And so if we have a triangle, how many sides does a triangle have? 3. And watch, I'm going to put, you'll see why I'm going to do this in a second. You won't see it right now. I'm going to put a word triangle. So we have one triangle, and we'll put sum of the angles. Okay? So if we have one triangle, that means we have 3 sides, we have one triangle, so what do? We go 1 times 180, which is 180. I'll show you why I put the 1 in front of it in a second. Let's draw another one. I'll just kind of use some extra space I have over here. Let's draw 1, 2, 3, 4 sides. Again, it's just kind of arbitrary. I didn't try to make it look like a square, rectangle, or anything like that. I just made a 4-sided figure. So this is a quadrilateral. Now watch what I'm going to do with this quadrilateral. Let's do the different color. Let's do this in red. Okay, watch. I'm going to take any vertex. It doesn't matter which one. Let's just take this one right here. Okay, no particular reason. And I'm going to go to a non-consecutive vertex. Non-consecutive means it's one that's not right next to it. So I'm not going to go here. I'm not going to go here. I'm going to go down here. How many triangles did I make? 2. There's 1 and there's 2. There's 2 triangles. So watch. So this is a quadrilateral, right? I'll just shorthand it to quad. How many sides does a quadrilateral have? 4. Now, after drawing that diagonal, how many triangles do I have now? I have 2 triangles. Do you see that? Okay, 2 triangles. So if I want to find the sum of the angles, what do? 2 times 180. Very good. Because each triangle has 180 degrees, right? If I have 2 of them, it's 2 times 180. And what's that? That's 360 degrees. So if I asked you, what are the sum, let's scooch this up a little bit more. What are the sum of the angles of a quadrilateral? What would you tell me? 360. Now we're going to do a few of these. I'm not expecting you to memorize each and every one of these, but 360 is probably one that you can memorize, don't you think? So 180 for a triangle, 360 for a quadrilateral. What's the next one? 5. Let's go pentagon. So let's color coordinate this, okay? So let's go pentagon. Alright, and just for fun, we'll draw a pentagon. Just 5 sides. It doesn't have to look like a perfect pentagon. 1, 2, 3, 4, 5. Okay, yeah. 360. It's 2 times 180. 2 times 180. So it's 1 times 180. It's because how many triangles you have, it's one triangle times 180 degrees. 2 triangles times 180 degrees. Okay? Pentagon. Let's draw the diagonal in the same color. So let's start at any vertex. It doesn't matter. I don't know. Let's just start right here. Let's go to the non-consecutive vertices. I'm not going to go here. Where am I going to go? Here. Start from that same exact vertex. Go to the next one, which would be there. Can I draw any more? No. So how many triangles? 1, 2, 3 triangles. Follow me? So a pentagon, let's change colors here. A pentagon has 5 sides. How many triangles do I get out of a pentagon when I draw the diagonal? I get 3 triangles. Do you see any kind of a pattern developing? 3 times what? 180. So there's 3 triangles times 180. What's that? What's 3 times 180? 540. Okay? So that means, does that mean each angle is 540 degrees? No, it means when I do what? When I add up all 5 of these angles right here, all 5 of those angles are going to add up to be 540 degrees. Make sense? Let's not keep drawing this out. I think we got the idea now. I will try a different color. Let's go this nice blue color. Okay. Let's go to the next one, which would be a hexagon.
Kelly McGee, please come to the office.
How many sides does a hexagon have? 6. How many triangles am I going to have? Do you see a pattern? Look, 3 sides, 1 triangle. 4 sides, 2 triangles. 5 sides, 3 triangles. What's the pattern? What am I doing though? What am I doing? I'm let's not think of going 1, 2, 3. What am I doing to go from 3 to 1? Say it. Subtracting 2, right? It's 3 what? Minus 2 is 1. Minus 2. Minus 2. You follow me? That's the pattern I want you to see. That's important. So look, 6 what? Minus 2 is 4. So that means there's 4 triangles. If I want to find out the sum of all the angles, what do? Take 4 times 180. What's 4 times 180? 720. Make sense? Let's skip a few. All right, that's skipping a few. And we'll go different color. What haven't I used yet? Oh, let's use that. It's like a tan or a brown or something. Okay, so I don't know. Let's go to decagon. How many sides is a decagon? 10 sides. Okay, what do I do to find out how many triangles after I draw all those things? 10 what? 10 minus 2 is 8. That means I have 8 triangles inside of a decagon. Does it make sense? If I have a diagonal from one vertex, I have 8 triangles. So what do? 8 times what? 180. Somebody do that for me. I don't know what that is. What is it? 8? No. Somebody do that. Who's got a calculator? Quick. 180 times 8. I should know it, but I don't. It's like 1080 or something like that. What is it? Oh, 1440. That's right. No, I'm not going to draw them. I said I wasn't going to draw the rest of these. What if we do 12? Do you remember that there is a name for 12? You remember it? Dodecagon? How about spelling it right? Decagon. There we go. So what is that? That's 12 minus 2, which is 10. So it's 10. We should be able to do this without a calculator. 10 times 180 is what? 1800. Okay? What if we did this? Let's try another color. What haven't I used? Green. Let's use that. Okay? What if I said, I don't know the name of it, but what if I said I had n number of sides? What does that mean? It means that it could mean any number, right? So how do I find out how many triangles? If I have n number of sides, what do? N minus 2. That's right. Because look what I did. I minus 2 to every one of the sides, didn't I? If I don't know what the number of sides is, if it's some unknown number, I still take 2 away from it. N minus 2. Make sense? So how do I find the sum of all the angles? I go n minus 2, what? Good. Times 180. Do you see that pattern? And that right there, I'm going to put it in a little box. That right there is how you find the sum of the angles of any number of sides in a polygon. For instance, Zach, you got your calculator ready? What if let's think of some crazy number like 17 sides. What if they asked, here's what they would ask you, to find the sum. What does that mean to find the sum? The total amount when you do what to them? When you add them all up, okay? The sum of the angles, they might say interior, I'm not sure, but the sum of the interior angles, that's what you're trying to look for. Of a polygon with 17 sides. So what's the rule? What do? We go 17, here it is right here. See this box? 17 what? Minus 2 what? Times 180. So that would be what? 15 times 180. Zach, give me a number. 27 what? 100? Okay. And there it is. That's all there is to it. That's not too bad, is it? They could give you crazy number of sides, like 100 sides. What if they say 100 sides? You'll definitely want a calculator for this. What's the rule though? Minus 2. So we go 100 minus 2 times 180. Now I know you could go 100 minus 2 in your head, but I'm just writing it down so that you remember how you get that. Okay? 100 minus 2 is 98 times 180. Zach? 40? Okay, look at that. So that means if you had a polygon with 100 sides and I wanted to know what all the angles added up to be, it would be this number right here, 17,640 degrees. Okay, that's how many degrees would be in a polygon with 100 sides. You okay with that? All right. All right, let's discuss another word. We talked about polygons. Let's go back to yellow. Let's talk about a particular type of polygon called a regular polygon. Okay? A regular polygon. Now, I'll tell you, let me pause this because I'm going to go find a couple regular polygons. Alright, I've got 3 regular polygons right here. What do you think? I haven't told you what a regular polygon is, but I've gotten 3 examples. Let's take a look at the triangle. The triangle is probably the easiest one to talk about. I'll just make it a little bit bigger. Why do you think that's a regular polygon? What looks like it's true? Elizabeth, tell me. Okay, all 3 angles are equal to each other, and all what? All 3 sides are equal to each other. So in order to be a regular polygon, 2 things must be true. They must, all the angles are equal, or congruent if you want to say that, and all the what? All the sides are equal or congruent. Everybody follow me? So when those 2 things are true about that one particular polygon, then it's a regular polygon. So this right here would be a regular polygon. What would be true about this? Look, if all these angles were the same, and they are, if all these are the same, that alone does not make this a regular polygon. What must also be true? All the sides have to be equal to each other. I'm telling you they are. You look to see if they tell you, or they could just say this is a regular polygon. Okay, this is a 8-sided figure, so they could say that this thing right here is a regular octagon, or this right here is a regular what? Pentagon, right. Okay, that would be a regular pentagon. So a regular pentagon all look exactly the same. All right, they don't look any different. They all look like this. A regular octagon all looks like this. What's a regular octagon you see probably every single day? Stop sign. Okay, so a stop sign is a regular octagon. All the angles are equal and all the sides are equal. Let's do this. Let's take a regular polygon. Let's start with a triangle since that's the one we're probably more familiar with. Change this to yellow. I want to find, and we've probably already talked about this, but we're going to do it again. I want to find all the angles inside each angle, not just the sum, but all the angles. So first of all, let's find the sum of the angles. What are the sum of the angles of a triangle? 180 degrees, all right? So we know how to do that, right? So that's the sum of all the angles. Now, how many angles do we have in here? We have 3. There are 3 sides, 3 angles, right? So what do I do with that 3 to find each one of these angles? That's right. I divide it by 3. Make sense? If I say divide it by 3, it means divide evenly. That means all 3 are going to be exactly the same. Blake? No, it's just midterm. It's just from the midterm. This is the first thing that could possibly be on the final. All right, so we go 180 divided by 3, which is what? 60. So that means each of these angles is what? 60 degrees. That's 60, and that's 60 right there. See that? So anytime you have a regular triangle, all 3 angles are 60 degrees. I think we've already done that before, haven't we? Haven't we talked about that? Yeah. Yep. So let's get rid of this stuff. Just save me some room. Let's go to the pentagon. I tell you what, let's do the stop sign since, tell you what, I'll take the stop sign without all the little marks. Okay, make it a little bit bigger. Oh, that looks crazy, doesn't it? All those things. And let me change back to yellow again. Okay. We're good to go. What I want to do now is I want to find each of these angles of an octagon. Now this is something we haven't done before. Okay, you probably wouldn't be able to do this unless you learn the stuff that we talked about today. Now you could, on the way home, tell your mom or whoever's driving, you know, stop right here, stop right here. Let me take my protractor and measure out the stop sign. That'd be kind of weird, wouldn't it? All right. Look, I'm kind of geeky, but I'm not that geeky. Okay, I've never done that. And I actually, my summer job when I was in college was actually working with signs. I actually put up signs. That was my job. I worked for Del Dot, and those orange trucks. You ever see those orange trucks go around? So if a sign would get knocked down, they would call the place, and they would send us out, and we'd fix the signs. So I was around stop signs all the time. Never one time did I ever take my protractor and go up and measure the angle of one of those stop signs, okay? But if we wanted to, we could figure out what it is without even measuring it. Okay, so first thing what we do is we find what all the angles add up to be. We've done it once, let's do it one more time. So there's 8 sides. What do we do to find the sum of all the angles? 8 what? Minus 2, right? And then times 180. So that's 6 times 180. What did we say that was? Is that 1440? Is it 1080? What was the 1440? 10 sides? So which one's this one? This is 1080? 6 times 180? Okay. I should have these memorized. I've taught this long enough. I can't believe I don't have them memorized, but I don't. So it's 1080. Does that mean this angle right here is 1080 degrees? No. How do we find each one of these angles if this is a regular octagon? Divided by 8, because there's 8 angles, right? Count them up. So 1080 altogether, but if I want to find each individual one, I just divide it by 8. What's 1080 divided by 8? 135. So that saves you the trouble of taking a protractor out to a stop sign, people giving you weird looks. You just know now that each of these angles right here is what? 135 degrees. Every single one of them. I'm not going to write it for all of those, but you get it, okay? Every one of those angles is 135 degrees. Make sense? All right, so that's how we can find each. So you got to watch the problem very, very carefully. They'll say octagon. Like problem 1 might say find the sum of the angles of the octagon. What would your answer be if it asked you to find the sum of the angles?
Add all the angles.
Give me a number.
135.
It's right there in front of you. What's the sum of all the angles? 1080, right. Why did it take so long? All right, look, it's right there. It's 1080. We already did it once, didn't we? Okay, so if I asked you to find the sum of the angles of this octagon, regular octagon, it would be 1080. You got it? Another problem, let's say problem number 2, could say find each angle of a regular octagon. Each. That means just find that one, or just find that one. What would that answer be? That would be 135. Do you see the difference? A lot of people get these mixed up, or they just always find the sum. All right, make sure that you understand what they're asking. If they ask for the sum of the angles, it's just n minus 2 times 180. If you find each of them, you take that sum, divide it by how many angles you have, and that gives you each individual angle. Does that make sense? Okay. What time do we get out of here? 1 on the button. All right. I'll tell you what. Let me go through one quick example for you. Hey, don't shut it down. What are we doing? Well, watch this real quick. I'll tell you what. This is what I'm going to have you do. There's an example that looks like this. It's on the 4th period geometry class. Look at that. It's at the very end of the. It's at the very end. And let me give you a worksheet to do. And you should be able to do most of it. There's some problems you might not be able to do because we didn't quite hit everything.